Hello fans, how are you all today? I've just picked up this Transonic TV. It's a 47-inch model TC-4778 LCD. Sort of 2011 I believe it's roughly came out. This one is said to have no turn on and flashing standby light. Nothing much to look at. Fairly plain, but there's sort of a bit of weight to it. Been trying to get it on its stand, being a little bit awkward, but I also just found out that even if it was on the stand, if I pull the back off, she's going to fall over anyway. So it's going to be on its side for this video on the floor. And the first thing to do is to verify the complaint. So there we're looking at the standby light, and if I push the on button from the remote, it doesn't even blink. Okay, so no power on, unless the batteries are flat. Hang on. Okay, we'll use the button on the side of the TV. Nope, not responding to the power button. So that's not a button, that's the IR receiver. Not responding to buttons or anything like that. I did notice this sticker over one of the screws is missing, or damaged. Maybe someone's had the back off, maybe something's not plugged back in if someone's played with it. Let's take the back off and have a look. Okay, what have we got? It looks like there's a couple of tweeters in the corner of the back, and they are soldered to the speakers. So we're going to have to actually unscrew the tweeters and to get the back off, and even the switches down the side. It looks like we'll have to unscrew that panel just to get the back off. It would be nice if the back could come off and the remainders were left on the chassis. It'll make it easier for servicing. Well, for a mass-produced consumer product, this is just absolutely disgusting. The cable that goes to the switch panel for the side, there's no connector on the side for it to plug into, and you can see there's the holes it would normally plug into. Perfectly good connector, but what it looks like they've done is they've either punctured out the connections from the side of the connector and soldered them onto the side of the board, or they've jammed bits of wire into the side of the connector and soldered them directly onto the board and covered it in hot glue. I want to see what they've done, but I'm afraid to pick off the glue in case it destroys it. That's what it looks like they've done, is just jam bits of wire in the side to make connection and then hot glue it down. It's just incredible. Who knows, maybe that's where the fault is. Oh well. I don't know if the remote actually works. Actually, as a quick test, what if I just pointed at the camera, here we go, and hit the button. Oh yeah, there you go, you can see that flashing. So remote works, so unlikely to be that, but yeah, that's amazing. And there's not too much going on inside this. Up the top we've got the backlight driver board. It's made by LG. It's likely got an LG screen in it. I've got a funny feeling LG might make the entire set, but not sure. Power supply on the right. Everything looks okay to start with. No bulging caps, so it's a good sign, or at least that I can see. There's a heatsink there that may have a few under it. I have to have a closer look. On the left we've got the main processing board with all of the inputs and the tuner, and yeah, the amplifier. What else? Also looks like it has speakers on it, amp, and Down the bottom we've got a little subboard that takes the signals off the processing board, converts it to the LVDS, which goes over to the right side under a shield to the right of the power supply there, and that drives the screen. So first I guess we have to check voltage rails and see if we can figure out what's present and what's not present, but the fact that it's got a standby light suggests that the standby 5 volt is present, and what we'll need to do, there should be a signal coming back from that to power on the rest of the power supply, so we can look to see if that's present. If it is, it's probably a power supply fault if there's no other rails. Otherwise, if that's not coming back, it's likely a faulty main board not telling it to turn on, so that would suck. But anyway, let's see how far we get. Alright, struggling to get a good angle here, but here's the output of the power supply. Here's the caps underneath there. They all look okay. Doesn't mean they are okay, but let's worry about that later. Here's our output. So we've got plus 5 volt standby. Looks like that'll be ground, but it doesn't seem to be marked. I don't think they'd have black as the plus 5 volts. So we've got plus 5 standby there, and then the blue is plus 5 standby. So we must have the plus 5 standby, and then the yellow one, probably the one that activates the power supply. And over here we've got 12, plus 12, a few grounds, and 24 volts. The 24 volt line goes to the main board. Whether that's being used to drive the amplifier side, I'm not 100% yet, but it's a interesting voltage to have going up there. I mean, there's also the 12, that line runs up with the 5 to the main board as well. Yeah, so there's an unused connector there that's got ground and 24, and then there's this connector. Now actually I think what this is, because that lines up with these as well, ground and 24, there's 2 connectors. This one runs up to the inverter board for the backlight. Pretty sure that if this had another set of backlights or 2 inverter boards, say there'd be another inverter board down the bottom on the left side of the TV, that would run power to that one, but it's only running the 1 inverter board, so just using the 1 connection. I don't know how many tubes they're running. What do we got there? 1, 2, 3, 4, 4. Looks like maybe 4 tubes. Okay, so there's our meter, and a lovely shade of, horrible shade of light. Now what do we got there? Have we got any power there? No power there. We got our standby. What have we got there? 5 volts. Okay, so 5 volt standby, and the yellow lead is also 4.2. Now if I try and turn this on, let's reach over to the power button, and we'd expect that to possibly pull to ground to turn it on. There we go. Now I'm clicking that, and that's not doing anything. So if we go to our 5 volt line, do they have anything? That's got nothing on it, and of course that's ground. Yeah, okay, so we have 5 volt standby with no control apparently from the main board. So we need to turn our attention to the main board, I think, and see what happens. I might try grounding that pin just to see if the board turns on, but I think initially, yeah, we'll have a look over at the main board, and we don't want to force power up something that might be under fault and might be about to explode if we did that. Okay, so now what I'm going to do is got to find out why it's not turning on. So we'll put my lead into the chassis for ground, and we'll start here with the on-off switch. So that's that button there, and it's likely going to have a voltage on one side that gets pulled to ground to tell the thing to turn on. And I would imagine that voltage is being possibly sourced from the micro. Not 100%, it may not be, but if there's a voltage present and it's being pulled to ground, then yeah, I guess we could trace it through and find out where the voltage is coming from. If there's no voltage present, it's definitely, we need to look for that and why that's not there. That could also be defective microcontroller, but I think the larger plane there is going to be ground, and we can see we've got 0 volts there, it's ground. And then if we go to the center pin, and oh, look at that, 0 volts on the other side of the switch. So wherever that on-off voltage is derived from for the power switch, it's not making it to the switch. Perhaps the fact that it's ignoring the remote control also suggests that the microprocessor is not actually turning on either. So we shall head in that direction. In fact, that's probably more like it if it's not looking at the remote control either. But anyway, we'll just find out which wire that button goes to, which color of all of these ones here. We'll just turn the set off, not that that matters because it's not doing anything. We'll go to resistance and trace it through. It's definitely, I think, the left, probably the left pin here. Although, how am I going to get in there? I don't want to break that hot glue. You find a little probe to push down in there. Let's just try the tip of the meter. There it goes. No. There we go. Second one in. I think the first one is probably ground. So we're looking for yellow, it looks like. Yellow. Well, we know it's connected through to the plug, so this dodgy bit of shit down under here is not a problem. And if we go through to the PCB, we can see that the PCB should also connect through to the switch, and it looks like it does, so the cable's alright. So we're looking down on the main PCB now for a reason why that's not waking up. There, we'll have to pull some of these connectors off, get the board out, have a closer look at where the power comes in. It's entirely possible that there's local voltage regulation here, likely drops it to maybe 3 volts for the CPU. That's looking like a switching regulator in there with a little inductor. Maybe that's not turning on. All good things to have a look at. I wonder if I can do that in situ. It's just awkward sitting down here on the floor and showing you guys that sort of stuff as well. Yeah, okay, I might just pop a probe on, say, that capacitor, and maybe the inductor. Maybe there's a diode on the surface I could probe. That's probably a voltage regulator hiding up in there. Looks like another inductor over here and here. Whether they're part of switching or not, I don't know. Yeah, possibly there's another little inductor down here, so it could be another little switching supply. Another regulator, possibly. Yeah, okay, we'll go in for a closer look as is before we pull it all out. Maybe if I tip the TV up the other way, we'll see. So having a closer look in here, we've got the voltage, 5 volt standby comes in through here. There's a couple of caps up there which could be power supply for something. They're fairly big, so I'd say they would be. I doubt they're speaker decoupling caps, but they are right beside the speaker plug. But anyway, a couple of inductors. As I said, there's an IC there. Not too sure what that IC does yet, and transistor there, which is presuming is going to be a regulator of some sort. Some more caps and an inductor, possibly a switching IC behind there controlling that rail, and then looking down a bit more, there's the heatsink for the processor. That's probably the EEPROM, some memory, a couple of memory looking like chips, and possibly maybe this is the rail for the CPU, who knows. I guess best way to find out is to look at the data sheet for that IC there and that IC up there, and see if that's what they do. But I guess a quick probe with the multimeter, and we'll see maybe if there's any other voltages floating around that might hint to us if anything's alive or not. So what if we grab, I'll just read out the values to you, but we'll have a look at, say, that cap there, and I've got 380 millivolts. It's not fluctuating, but it's not a lot. Yeah, in fact that's kind of nothing. No, if I take the meter off, I've still got that much. Just a stray. What have we got there? Well, there we go, 3.3. So that's an unfortunate start. We've got, yeah, 5 in and 3.3 out. If we have a look down here, we've got nothing on that one. Nothing there. Oh. Nothing there. So we've got no voltage here. So that's not a good sign. But we've definitely got 3.3 up there. I would expect to see something a bit further down, unless that plays doesn't really come into play until, because there's a 5 volt line that comes in, that red wire up here, that may only feed the slot, so this won't be working until that is resolved. So perhaps that 3 volts is actually standby circuit. I think I may have to pull the board off, try and trace it through a bit better. So as I thought, this chip is an MP-1482 buck regulator. So it's designed to step down voltage, and it will be switching across this coil, and one of these will be the output capacitors. Now I think what I'll do first is just see if there's supply voltage to that, to get an idea if it should be functioning, and whether or not that's supposed to be on as part of the standby circuit. So pins, pin 1 is our input there. Where's our view? There we go. Pin 1. Pin 2 is our input there. Sorry, 1 is something marked BS. Haven't looked at all of it. So pin 2 is our input, so we've got voltage in, and I'm expecting 5 volts there. Pin 7 should be also 5 volts. It's our enable pin to turn it on, and pin 3 is our switching pin. Goes across through to the inductor and out. Given how tightly packed it is on the board there, I don't think I'll be able to measure without removing the board, but I can measure pin 5, which is our feedback pin, and I would expect to have some voltage on there. It's a voltage divider, of course, with that resistor to ground, but there should be some voltage on there, which would suggest that it is working if it's got input voltage. So we will have a look at that. So looking for pin 1, which is going to be No, pin 2, it's going to be down the left, it's pin 1 at the top. But they did join them in the data sheet, but this one appears to be separate, so I'll probe. There we go. And we don't appear to have any voltage on there at all. I'll just have a closer look, make sure that is pin 2. Yeah, that's definitely pin 2, so there's no voltage there. It comes up to this transistor here, so we can probe there, we can probe the other side of that transistor, which has nothing on it as well, and we can probe the third pin there just to see. So there's nothing there, so not 100% sure yet where that gets its voltage feed from. It does head up the top there, and may be powered by the 24 volt rail, or possibly a 12 volt rail. Again, we'll need to pull the board off to have a look. So at this stage it's quite normal for that circuit not to be functioning, as there's no input voltage. Now this IC up in here is an R2A15122. Quick search found a 15120, which is a D-class power amplifier IC, so it must be some derivative of an audio IC, amplifier IC, and given its proximity to the speaker connector, I'm pretty happy to go with the fact that that's what that is. Well, I guess this simplifies things. Absolutely nothing to look at. So we can focus all our attention on the top side and see how lucky we get. Yeah, no, can't be something that difficult. I mean, what else could it be? What else could it be? Micro must be running at to some degree to know that the switch was pushed, so we're going to have to get power down to here. It's not happening for some reason. Okay, so here's what I've just nutted out. Having a look over the circuit, so our focus isn't the greatest. There we go. So coming in through here is our 5 volt standby. That goes to this cap and comes through and regulates to 3.3. None of this is active until we get our 5 volt supply in. We get 5 volt through to here, which will in turn run that there, and we get our 12 volt through to this cap, which races off over to the input side of things. This looks like a 5 volt regulator there as well, and whether they use 12 volts for the tuner maybe. We've got when our 5 volts comes in, it comes up through here. There's a fuse there, that's our USB, so that's 5 volts to USB. There's also 5 volts here that goes up to, interestingly enough, the infrared panel, but it doesn't really do us a lot of favors up there in standby, because infrared, the remote should still be able to function. So at this stage I'm still tracing through where the power switch goes, but it's looking more like it comes off to the CPU. We have our 3.3 volts heads off over here and into the CPU. So a couple of things it could be: dead CPU, maybe it's a broken connection to the board, quite possible the ROM has failed or become corrupt, so the program that it runs on is well, it's unable to boot up, so to speak. I've seen that happen in TVs before. Maybe we can check the crystal there and see if it's if there's any signal, if it's oscillating. If it is, that's because that's a crystal on its own and not a standalone oscillator. That would tie in with the CPU if that's oscillating, there's a good chance that the CPU is okay. There's no low resistance on that 3-volt line, so it's another good sign. But if the EEPROM's bad, we'll put a scope on the EEPROM data line and see if it's actually trying to start up and read data off it, or if maybe it is completely dead. But yeah, that would explain why there's no voltage on the power button and why it's ignoring the infrared. So yeah, perhaps the next step is to put a scope on it and see if it's actually booting up or attempting to boot up, and see what we make of that. So I've got 5 volts coming into our 5-volt standby line from my bench supply. It's just easier to work with the board out of the TV, and I've hooked up the scope, and we'll have a look at the crystal. We'll see if that's oscillating. We'll have a look at the data lines on the EEPROM, see if it's being accessed. Okay, let's put some power on it and flip the board over so we can get the crystals, pins on the crystal. And what have we got? Nothing there, nothing there. Well, that's really not a good start, and I guess there's bugger all current being drawn as well, which is also indicative of the fact that there's nothing really going on. It could just be a low powered thing. I'll check the EEPROM anyway. What have we got? Have we even got power on it? What do we got? Oh, what's that? Maybe something is oscillating. I got something wrong there. What's going on? It's on pin 1. I haven't looked at the data sheet for the EEPROM yet. Oh yeah, there's a bit going on there. 2 and 3, 4 and 5. Got some more traffic on 5, 6, 7, 8. That looked a bit random. Tell you what, go back to DC coupled again, and there's our voltage, which is going to be 3.3, and maybe this thing's running an internal clock until it gets going, and then it might use the external crystal. That's entirely possible. But yeah, that's interesting to be accessed constantly while it's in standby. So I think there's two things it could be. Either the data or the EEPROM's corrupt and it's not booting up, so it's not verifying anything, or perhaps it wants to do a power on self-test, which is not happening. Maybe when the power's applied, it tries to activate the main power supply, and when it finds out that nothing happens, it stays in shutdown. So having a closer look in here, the power on pin to the power supply goes to this transistor, which one side goes to the 5-volt standby, so that transistor must be turned on to feed what we're seeing, almost 5 volts back out there. For the set to turn on, then it must turn that transistor off so that this pin is 0 volts to tell the power supply to turn on. I think, what if we force the power supply to turn on and see what happens? We could even maybe monitor that transistor there, although I'd say there's nothing, there doesn't seem to be anything wrong with it. I did test it, so it's being held in an on state, but we could bypass that. Even if we pull the wire out of the plug, we'll just cut it and rejoin it later if need be. Just so the power supply is forced to turn on, we can see what it does in response to that. Well, you may or may not believe this, but this is what happens when you don't understand circuit design. Well, sorry, when you don't understand how the manufacturer intended anything. Because I had none of the other rails, and I'm sure I did check those, we only had the 5-volt standby, we didn't have any other rails. I thought it must be in standby with the 5 volts on the power on line. So I thought, well, with it unplugged from the board, so that lead is low, I'll just check what the power supply does with power on it. And I noticed that it made a noise when I had it plugged in before, but I thought that was just the sound of the 5-volt oscillating, standby circuit. And when I checked, I had no voltage coming out, which I thought was quite odd. So I shoved some pliers across the 5-volt standby and power online, so they have 5 volts on it again, and then I heard it buzz into life. And when I checked the other rails, they briefly came up to what they should be and then started falling off pretty quickly. All the rails but I think one. No, I just checked again and we get 5. We get all the rails, but the power supply doesn't stay on for very long. So given that that's the only lines in and out of the power supply, I'm thinking it's probably a power supply fault. And because those voltages are dying off, yeah, it should be running. It should be running. I don't think this would be load detection. Other than overload, I don't think it would care that the main board's not plugged in. But alright, I'll plug the main board back in and just double check some things. Okay, so if I switch the power supply, or switch the TV on, switch the power supply on, it'll briefly energize, and then you'll see it drop off, and this happens to all of the rails on it. There we are, and it flicked up to 24 volts and shot back down. And the 12 volt and 5 volt rails, they all do the same thing. Even with I've unplugged the connectors just to isolate the inverter board, a backlight inverter, and the audio amp, which is the 24 volt line, and none of them are pulling it down. They don't have overly low resistances on them anyway, so I don't believe it's that's causing the power supply to shut down. The 5 volt power on. The 5 volt power on is staying present, so I guess that confirms some kind of intelligent life from the main board. Yeah, like it is actually trying to power up and maybe, like I said, maybe run a self-test and then shut down. I've seen TVs kind of power up and then shut down. So I've had a good look around for the usual suspects, like well, dry joints, anything exploded, that kind of thing. What we have here is there's 2 transformers. The little one on this side, which is, if I go over here, there's a little one, there's the main one. The main one generates our 24 and 12 volt lines. The little one here is generating our 5 volt line, which comes in through, we've got capacitors across it there, we've got an inductor here, through the inductor to the trace that comes around here, that gives us our 5 volt standby on, and this transistor is on the same line. That goes to our main 5-volt rail, so when power is applied to switch the rest of it on, this also turns on through a roundabout method and passes 5 volts through. So the 5 volt standby line is also the main main 5 volt rail when running. And down here we've got our second larger transformer that has our 12 volt and 24 volt lines coming off it, and the 24 volt line is used for the backlight and the audio, and that comes off the transformer. There's some capacitors for that one. There's a big inductor. It goes through here to out to the plugs, and there's a line that's taken off here, which goes down to the opto-couplers here for feedback, and there's the power supply on 5 volt in comes up through a line to here and through to these opto-couplers, so it's isolated on-off control. And we've got monitoring of the 24 volt line. We have what looks like monitoring of the 12 volt line. This 12 volts comes down through here and also off into the circuit for the opto-couplers. There's 2 opto isolators there, and what I think is happening is that the main supply is not getting the required feedback, so it's shutting down as a safety precaution. It's interesting that I noticed the 24 volt line appeared to shoot up to 25, or it could just be my meter being slow. I should put the scope on it, but if it's over voltage, going over voltage, then it will shut down. We'll check the opto-couplers, see if we get some normal readings off those, I guess, and see if we can power it up on the bench, maybe make a note of to what's going on, get a feel for things. So if we check our opto-coupler, we've got the input side, which is the LED, internal LED, and we've got 1 volt drop across there. If we check the other one, we've also got a volt drop across there. I'm pretty sure that's okay. If we check the other side, we're going to have nothing because, well, there's no light inside it, so it's not turning it on. So I think they're okay. Okay, I'll take some measurements powered up, and I'll just have to read them out to you because I'm a bit cramped for space to show the meter as well. But I'll just flick this thing off and on, and we'll see what it does. I've got a couple of wires going over to the PS on, so I can just join that up and we can watch. So if I go to our 24 volt line and flick it on, hear it start up briefly and drop off. We flick it again and again and again. Every time it fires up, it's shooting right up to nearly 30 volts. That'd be a good one to put the scope on and just capture how high that's shooting, because it sounds like an overvoltage shutdown really. Okay, I'll pop a scope on that rail and just see how high it actually is overshooting. It'll be interesting. I'm going to switch her on now. So I just stopped that, and at 10 volts per division it shoots well up over to 30, almost 32 volts there. So that's mildly concerning. Let's have a look and see perhaps what the other rails, if they're overshooting or not. So I'm going to have a look at the 12 volt rail now. That one. That's not 12 volts. Try that again. Goes up and holds steady at probably 8 or so. I wonder where that's coming from. We'll double check that again. And that's 24, and I'm sure that's 12. I wonder if our 12 volt line's being pulled down. Okay, so we're probing around with the scope, and we're on 5 volts per division. If we have a look, we know the 5 volt standby is working, so we can use that maybe as a comparison. So if I probe on the Opto-coupler for the say 5 volt line, I'm getting, there's 2 Opto-couplers, so I've got one there, they've both got 5 volts on each side, on the input side to the Opto. That one's, sorry, no, that's not 5 volts, that's a bit more than 5 volts. That one's got, looks like 5 volts across it as well. So if there's 5 volts, the same potential on each side of an LED, it's not going to light up. There has to be a lower side to it. There has to be more negative, one side more positive in order for current to flow and light up. So because there's 5 volts on across both pins, these Optos are in the turned off, and so the main power supply is not going to be running. So now if I watch one of the pins while I switch this, connect the power on wires, we can see it drops to 0 volts. And if I watch the other side, that drops, but not to 0 volts. That goes to probably about 1 volt, I think. Yeah, it's 1 volt. So 1 volt, and the other side gets basically grounded, so that turns that Opto on. Now if we have a look at the second Opto there, just sitting at 5 volts, if I run the PS on wires, okay, no change there. And if I check the other side, and I get no change there. So that's interesting. So I wonder what that Opto is supposed to do. When it's not giving me any change, maybe that's our problem. Maybe there's no feedback from wherever that comes from. So that's interesting. Just try that one more time. No, nothing there. And if we have a look at our output still, where's an output? There's an output. If yeah, still spiking up and turning off. If I have a look, let's have a look on the higher voltage rails, so the 24 volt rails and so forth. If I have a look on this pin, and we see what we get when I turn it on. We get no sign of activity there, but I believe that pin goes to ground, so that's expected. On the other side, we see a very tiny blip, which is probably about 1 volt, but it doesn't stay on for very long at all. If we have a look at the second Opto, we have a couple of spikes where it tries to start up. Fast running out of batteries here. So if I have a look at the second Opto, as I was saying, we switch it on, we get a couple of blips as it tries to start up and fails. And if we look at the other side to that, we get the same pattern at almost the same level. So that's interesting, because if they're both the same level, we're not going to get light across. If we change up the volts per division, just to see if we can get a bit more resolution there and see how close to each other they are. Yeah, whoops, too far. We'll go 2 volts per division perhaps. So I did that twice in a row. I'll do that again. So you can see there, I just stop that, they all appear to be fairly equal height. So whatever's coming through that path to that opto is maybe not balancing, but it's what I'm more interested in is perhaps that first opto-coupler next to the 5-volt rail, and we want to find out why that one is not being energized, whether it should be. We'll look at what's going on in the circuit, or whether it's normal to not be energized, and maybe it's some sort of fault opto, or maybe it's driven by well, there's no other wires coming back from the main board. Okay, we'll have a closer look at the circuit. Let's take a measurement on the secondary side, well, the primary side of the opto-coupler. We've got the 2 opto-couplers here that we looked at. This one with the waveform that looks the same on both of the input pins. Of course, this one that looks a little better with ground on one side. Now, if we connect power supply on, well, checking, say, this pin of the supposed good rail, when I turn that on, I get 5 volts. And if I check that here, which is on the other pin there, and turn that on, I get 0.7 of a volt. So that's based on how turned on it is by the secondary side there. And if I look at the other one, what I can see here is that this side goes to ground via a 1.5K resistor that travels off up to here, up to up through here, which ends up going to ground. And this side, when I turn it on, we get 3.2 volts. So I would expect there to be something on the other pin because of that 1.5K, and however turned on that transistor is, you might think there might be some voltage there as like a voltage divider type, possibly. So if I turn it on and I get nothing show up there, so I wonder if this is responding to the input or if it's not. Would the 3 volts on this side be pulled down any amount in response to that? It's quite possible that it should be pulled down a bit, because that could be the voltage that varies for the feedback for that particular rail. It might be monitoring this voltage instead of so much what comes out there. Probably should just draw the circuit out, or better yet, look for a schematic. We might find one. We did find one in a previous video for whatever, I can't remember what model that was for. So if that's perhaps supposed to be pulling down that voltage there to ground, and it's not, or it doesn't appear to be, then I wonder if should it be 3.2 volts on there as the reference. So what if we remove the opto-coupler and turn it on, and then measure it and see what it says. Perhaps that'll be a way of testing it. If it still says 3.2, maybe this opto-coupler is not actually functioning properly. We could try switching the optos over and see if we get a different response. I have removed the opto-coupler, and I'll show you the meter then. So we're expecting 3.2 volts on the input there. So if I switch that on, as you can see, look, it's still 3.2 volts with no opto-coupler in place. We know that the other side goes to ground, so we're not going to see anything there. So yeah, maybe it is the opto-coupler not switching on and pulling that signal down to give it its method of feedback. But I think what I'll do next is we'll take the other opto output, is the one beside it, and swap that over and just see with exactly the same opto, so we'll know if there's a difference then. Okay, with the other opto in, who thinks it's going to work? Who thinks it's going to smoke? Probably not going to work, probably won't even smoke either. I'll turn it on, and I have no volts. Well, that's interesting. Try again. Hold the phone, turn the power switch on first. There we go. Right, on, and I have 2.5 volts. My meter slipped off there. Let's just double check. 2.5 volts. Well, that's a different reading. That means it is giving some variation, and if I check the other pin of the opto, we can see a voltage come up on there now instead of just being ground all the time. I think we may have just proven a dead opto-coupler. This is why you don't throw anything away. This is from the pantry of electronic crap, and it's a power supply from a Toshiba Tegra LCD TV that was going to be one of my videos and turned out to be a complete write-off. Well, I couldn't be bothered waiting for a part from China, and ended up using other parts from it for another well, the other LCD fix, probably the last one that I did. They had the backlight issue. Anyway, down in here we have two opto-couplers, so we can have a choice of either. I'm sure they both work, although this power supply did have a bit of a release of the smoke. So we'll pop them out and see if they're going to be suitable. But I think on the whole, optos, I haven't really done a lot of research into optos, but I think they all pretty much function in the same way, in the same sort of spec. So we'll give it a shot. Here we go, that's the old one, and that's the good one. So if we measure across the input pins that come from the secondary side that run the built-in LED, and I'll just do a quick check in diode mode. If we look at the old one, that has a 1 volt drop across it. If we look at the new one, that has a 1 volt drop across it. So that should be okay. By the way, just remember when you're measuring the voltages on the primary side, you have to reference the negative for that side. So here's the negative. We've got a wire attached to the main capacitor on the input there, so it comes mains in through a bridge rectifier and into the main capacitor. You have to use that negative as the reference for measuring any voltages on the primary side. You can't use the negative on the ground, negative on the secondary side. You'll get completely weird readings, so just keep that in mind. So just clip that back onto my meter. Also remember, I'm not using a scope on the primary side. I don't have an isolating transformer, and I can't be bothered hooking my other scope up to the bench supply to isolate that, which I have done before, but I don't think we need to do that in this case. So now we're going to turn it back on and make the measurements across here again. Remember, the top one was the one that seemed to be okay. It was giving us a 1 volt on the output, 0.7 volt on the output. This one was 3.2 volts and it wasn't changing, and when we swapped the Opto we saw it drop to 2.5 volts. So I'll point you over at the meter again. Okay, so now we're going to measure. We'll do the first one and make sure it's still 5 volts. It should be, but this is the new Opto-coupler. We should have 5 on one side and 0.7 on the other, or whatever we had before. So here we go, and we have our 5, and on the other side we have our, if I can get a good connection, come on, nothing. Oh, well, that's not ideal. Maybe that Opto's no good either. And on the other one we have now our 2.5, and on the other side we have something else. Oh, now we're getting nothing on the other one. Okay, let's see what's happening on the primary, secondary side, I should say. There's our input there. We've got nothing there. Oh, bugger. Oh, we've got nothing there all of a sudden. Let's have a look at our output voltages. Turn it on, and what have we got? Oh, at 11.8 on the 12. That's interesting. It's not dropping off. Do we have 24? There's our 24. We should have our 5. That's fed by the main 5, of course. But it's not giving up. That might actually be fixed. So what does that mean? If the other Opto was bad, perhaps this forms some sort of some kind of balancing circuit. The other Opto is not driven unless it's out of balance, because if I look at the input to the other Opto now, it's nothing, absolutely nothing. But on the input to the one that's faulty, we have 10 volts on one side, 9.4 on the other. So obviously, yeah, we're getting current through there. So this little circuit must be some kind of balancing circuit to give feedback such that stable or not. That's kind of neat. Oh, I think we might have fixed this one. Let's put it back in the set and see what happens. Now for the big reveal. We'll turn it on, and we should see standby light come on here, unless the thing's going to power up straight away. I don't know what this does, this TV, as far as power on sequence, but here we go. Switching on. So we have a standby light, but will it turn on? Let's hit the button on the remote. Oh look, we have a green light. Something's alive. Do we have a backlight? Any minute now. There's our backlight. It's probably got a message right in the middle of the screen that we can't see. Oh no, it's got a message down in the bottom left corner. There we go. And the usual no signal. How about that? Well, another one saved from the landfills. Thank you for watching. We're almost up to 2,000 subscribers now, so I thought I'd better do something. It's been a while since my last video, so I jumped online and found a couple of dirt cheap TVs, and I've got another one to come after this, so hopefully that is resolvable as well. But hopefully you learned something there, and you have luck with whatever you're working on. Catch you next time.